Hello everyone, welcome to lecture 3. In this video we will discuss if statements and flow control in C++. But before that, let me review some of the things we discussed earlier. As we've discussed before, when we organized code in C++, a common mistake is to have multiple main functions. If there are, for example, two main functions, or there are two code files and each of them has a main function in it, then the code will not compile. There can only be one and only one main function in a C++ program. So, for example, the structure of the program could be like this. You have int main, you open curly brackets, you have some code in here in the main function, and then you close the curly brackets. And that's it. You cannot have a second main function anywhere else. And int or integer is the type of number that the main function will return. That you can change to something else. For example, you can write void here if the main function doesn't return a number. So remember, when you write a program, when you construct a project in C++, and you have multiple C++ files that work together in a single project, only one of them can have a main function, and you can only have one main function in the whole project. Otherwise, the project will not compile. If you want to remove a file from a project, you don't have to physically delete it. For example, if you're using Visual Studio, you can simply go to the Solution Explorer on the right or left, and then you'll see a file that you want to remove from the project, and you can right-click on it and click on Remove. Then you'll have a pop-up that will appear, and you can select Remove again. You don't have to click Delete, just click Remove, and that will remove the file from the project. So if you do that, it is not going to be included in the project. It's not going to be compiled when you compile the project. The file will still be there, so you can still use, edit and copy the code from that file, or include it later. But it will not be included in the project. A good practice, if you're solving problems and you're experimenting and practicing, is to use comments. So as we mentioned earlier, when you use /* you open a comment, and / closes a comment. So you can wrap these comment symbols. You can wrap a block of code with these comment symbols, and then it will change color in your editor and it will be commented out, so it's not going to be visible in the program. Another issue we discussed earlier was uninitialized variables. Initializing a variable means giving it a value for the first time. Using an uninitialized variable is technically legal C++ code, but usually it's a mistake. So here, if I declare double x and I don't give it a value, I don't initialize it, and then I declare another double y and I state that it's 2 times x, but x does not have a value, so how can I multiply x by 2 if I don't know what number x represents? So if I try to print out the value of y, I'm going to get a nonsensical answer. So you may not even notice that you've made a mistake in this case. So for that reason, it's best to give a variable a value when you first declare it, whenever possible. And then you can change the value later on if you have to in the code. If you're using Visual Studio, you're going to get a warning when you compile the code. and that's going to be in the error window. So you can click on View, Error Read List, and you'll see this kind of error. And you can also see that when you run it in debug mode. And then in that case, the program will stop when it gets to that point. A very important issue, and something that many students get wrong, is integer division. You have to be very careful when dividing integers, because the result is not what you would intuitively expect. So the result of dividing two integers is an integer in C++. So the result will very likely be truncated. So for example, if I try to declare an integer m equals 5 and an integer n equals 4, and I try to compute the ratio m divided by n, I'm not going to get 5 divided by 4. I'm not going to get 1.25, which is what you would expect. Instead, the output is going to be 1. Why? Because m and n are integers, so any mathematics you do with integers has to lead to another integer according to the way C++ is constructed. So the logic is you divide m by n, then I get some number, and then I truncate that number to the nearest integer, and this is 1. If you want to calculate this fraction numerically in a correct way, you have to either replace these definitions. The definition of m should be double m and then a double n, and then that division will output the correct result, 1.25. Or you can convert these numbers m and n to doubles before doing this division. So remember that is very important. Many people make that mistake. I see this mistake again and again in coursework. So that's very important. Don't make this mistake. If you're going to divide numbers, make sure that they're doubles and not integers. The same is true for multiplication, of course, and other numerical operations. So, for example, let's try to see a similar problem. The numbers that are entered directly in the code are called literals. For example, I can define an integer x equals 2. 2 is a literal here. Specifically, it's an integer literal. 2.0 and 2 point are double literals. So if you use 2 point, that C++ knows that this is a double. If you use 2.0 to define a number, C++ knows it's a double. If you just use 2 without a dot, C++ knows this literal is an integer, and it will handle it as an integer. For example, let's try this code. I'm going to open up, let's use CLion this time. So I'm going to open up CLion and try and run this. Okay, so I'm going to create a new project in C++ 20, and I'm going to call this literals. Let's zoom a little bit here, and let's place this piece of code on the right, and this piece of code to the left. Okay, so by default, C-Lion created the hello world program. I don't want to keep repeating this standard library command here, so I'm going to type using namespace std and then semicolon, and then let's type this code. So double x equals 7 divided by 4, and then another double y equals 7.0 divided by 4.0, and then let's try the cout command. So I'm going to override the hello world, and instead I'm going to output x. Now I know I don't need this std call anymore because I'm using the namespace std here. So I can make that command shorter, and then I'm copying and pasting this piece of code, and I'm putting y here. I don't really need this to return 0. I'm going to comment it out. And let's run this and see what happens. Okay, so as I warned earlier, you have a warning here, actually. So we have a warning. It says that result of integer division used in a floating point context, possible loss of precision. So you see that this piece is highlighted by the compiler here, and you get warned that you may be making a mistake. And if I click here, I see a warning. So the warning has been highlighted actually. So what happens is C++ interprets 7 as an integer, 4 as an integer. It divides 7 by 4. The result, of course, is not gonna be an integer, it's gonna be a double, but C++ is going to round to the nearest integer. Why? Because operations between integers have to result in an integer. So 7 divided by 4 has to result in an integer. So the result will be rounded down to the nearest integer. If, however, I convert these numbers to doubles by using 7.0 and 4.0, then we get the correct result, which is 1.75. I could also just add a dot, so 7 point and 4 point would be enough for C++ to understand that these are doubles. So let's run this, and I still get the correct result. So remember, very important, if you're going to divide integers, the result is going to be an integer that's rounded down to the nearest integer. Okay, so let's consider different ways to convert integers to doubles and so on. Different data types can be converted to one another, either explicitly or automatically. There are several methods for explicit conversion. For example, if we define an integer a equals 7 and another integer n equals 4, if I do a divided by n and I define that to be a double x, no conversion will take place of a and n, so I'm going to get the wrong result, as we just saw in the previous example. you can use a C-style cast to convert a and n to doubles. So that syntax will be double in parentheses a, and then double in parentheses and n. And that would create a to a double and n to a double, and then it would do that division, and then we would get the correct result. So let's try and do that in our code. So actually we'll just try the next example. So this is probably the easiest way to do it. That would be a function style cast, and then you would just say double and put a in parentheses, and then double, put n in parentheses. So that treats a and n as arguments of a function, and the function is a double function. So it converts anything that's inside it to a double. So let's try and say double 7 here, and then double 4. And let's see what happens. This time there's no warning, and we get the correct result, 1.75. Another way is to use a C++ style cast, which means I can use this class. This is a template, so you could use this static underscore cast double, and then apply that to a, and then the same class applied to n, and that could convert a to a double as well, and n. Sometimes the C++ style cast can be safer, but the C style cast is also fine for examples with simple numeric variables. So for the most part, it should be fine to use just double a and double n and so on, this type of syntax for the purpose of this course. You can also have automatic conversions taking place. For example, if I define a double x which is equal to 3, then I've already told C++ that x is a double, so it's going to convert this 3 to 3.0. It's going to convert it to a double when I'm initializing it. Also, if I declare an integer k that's equal to 2, and then I declare another number y, and I say that this must be double, and I set it equal to k, then C++ will convert this integer to a double again. So these are implicit conversions from integer to double, which happen upon initialization. These conversions do not lose any information because a double can exactly represent all the possible values of an integer. We can also make conversions that might lose some information, which is what happened earlier when our integers got converted to doubles, but there was loss of information upon division of those integers. So here, these commands are legal, but the compiler will probably give you a warning. So if I define a double x that equals 3.4, and then I try to convert that x to an integer, and I say int k equals x, then that k will be equal to 3. So C++ will round this down to the nearest integer, and we'll set k equals to equal to 3. So you have some information loss, so 0.4 gets thrown away. You can also try a float. So if you remember, a double has around 15 or 16 digits of precision, and a float has around 8 digits of precision. So if I take a double and set it equal to a float, then the last 8 digits of accuracy will be thrown away, and C++ will just keep around 8 digits of accuracy, and then set that equal to y. So if I had more digits of accuracy here after 3.4, only the first 8 digits would be kept and the rest will be thrown away. So converting a double to an integer truncates the value, and converting a double to float loses some decimal places of precision. Finally, let's discuss the modulus operator. So sometimes we do want to do an integer division, but we also want to compute the modulus, or the remainder of that division. So for example, if I have an integer that's equal to 7 and another integer that's equal to 4, then the quotient q is a divided by n, and if I do that, C++ will give me the quotient. So roughly speaking, it will do the division and round down to the nearest integer. And then you can also ask for the remainder. So R here is the remainder or the modulus of this division, and we use % to denote that in C++. So if I ask for a modulus n, I'm going to get the remainder of that division. So mathematically, the relation between these 4 quantities is a equals n times quotient plus the remainder. So we can try and code this up. Just to see it. Okay, so let's try and define an integer. A equals 7, and then an integer n equals to 4, and then an integer q that's equal to a over n. Again, be very careful when doing this. Here we're doing this on purpose because we're not going to lose information, because we're going to calculate the remainder. And then another integer, that's the remainder, that's a modulus n. And then I'm going to use cout q and the line, and then cout r, and then end the line. Okay, and let's run this. Okay, so we get 1 and 3. So that's what we expected. So a is 7, and that is equal to 1, which is a quotient, times 4. So 1 times 4 is 4. And then what's the remainder? Well, we have 7 equals 4, and the remainder must be 3. And that's what we get here. Okay. So the modulus is clearly defined when a and n are positive. It's the remainder of that division. And there are various conventions when one or more of those integers is negative. You can look it up on Wikipedia. In C++, the integer division truncates towards 0. So if I use -7 divided by 4, that will result in -1. And then to satisfy the relation that I just mentioned, -7 modulo 4 must be equal to -3. So when a and n are both positive, then modulus is just the remainder. That may not be exactly true when a and n are negative, or one of them is negative. Okay, so now we've discussed the command cout, how to print out commands or information on the screen. Now, how can you type in information? How can you input information to your program? One way is through your keyboard, and you can input to the program using cin. So if you type cin and then greater than, then the variable that follows will be input from your keyboard. So if I declare, let's say, an integer k, and I don't initialize it, and then I can use cin greater than, and then k, then the program will ask me to type something, and whatever I type should be an integer, and then the code will take that as input, and then next thing it will do, it will add 3 to it and do cout. So it will output whatever I type plus 3. So what we have to do is wait until the program reaches that cin. It will wait for input, and then after we type that number, we have to press the enter key. So to use that, we need to include the IOStream library, just like for cout. So let's try and do that. So I'm going to overwrite these commands. I'm just gonna have an integer k, and then I'm going to type cin and then k, and I shouldn't really initialize k, since I'm going to initialize it when I input using my keyboard. And then I'm going to cout k plus 3. And then end the line. So let's run this. I already have the include IOStream library here. So the program is running and it's waiting for input. Yeah, it's running. So let me type 7, for example, and then I'll press enter, and then the program will cout k plus 3, which is 7 plus 3 is 10. So it printed out the number 10, and then it finished with exit code 0, which means everything ran correctly. Okay, so you can also try and control the style of the output. When we use cin and cout, these are C++ style commands. You could use C style commands for input and output that we will not use in this course. When you write C, then usually you use the commands printf and scanf. So printf will print something out, scanf will take an input from your keyboard. But we will not be using those. We will stick to C++ style syntax here. Okay, and finally the main part of this video. So far our code is just a series of commands that go linearly one after the other. So first do this, then do that, and so on. However, when you write complex programs, usually you want to control the flow of the program. So if this, then do that. Otherwise, do something else. So in that case, these commands will branch out to different parts of the code. And we want to be able to control which part of the code will be executed under what condition, and which part will not be executed. So to control the flow of the program, we use if statements. So we're going to cover if and else, as well as loops. Loops involve a for loop when there's a predetermined range, or a while loop when you have some condition for ending the loop. We'll discuss those later, but for now let's discuss the if and else statements. So an if statement checks if some condition is true, and if it's true, then it carries out one or more commands. For example, you can have a definition of an integer at h equals 3, and then have an if statement, and the condition here is h greater than 0. So that means h is positive. So if this condition is true, if h is positive, then you can print out on the screen the sentence h is positive and the line. And that's the end of the if statement here. So inside these round brackets is a statement that is either true or false. If it's true, this piece of code will be executed. If not, it will be skipped, and the program will go on to what's after the if statement. Sometimes you want to have multiple conditions. So what happens if it's not true, for example? So let's define an integer h, another one that's k, and then we have a condition if, and then the test is k equals h. So that checks if k is equal to h. And if that is true, then you print out on the screen a phrase equal. And otherwise, that's so otherwise, or in other words, else, something else will happen. So if they're not equal, then if they are equal, then they are not equal. So if the first statement is false, then it will move on to the next statement. So it will print out the not equal. So in this case, h equals 3 and k equals 5. So obviously k equals h will return false, and then that will not be executed, and instead the program will go into the next branch of the if statement. So this will be executed, and not equal will be printed out on the screen. Now, we may type this so that we can visualize it easier when we write code, but these commands could be put on the same line. So everything that follows this if statement could be right after the if, like this, and the else could be directly followed by what happens when the else statement is true. Now, if we have more than one command that we want to execute after an if or an else, then we need to put the code inside a block using curly brackets. So that's the usual way to define pieces or blocks of code in C++. So, for example, again, we have the h and the k we defined earlier, and another number that's an integer, and we use that to count and increase the value of that number every time something happens. So in this case, every time the if statement is true, we increase the value of num equal by 1. So this is what this command does. So now I want two commands to be executed inside the first if statement. So to accomplish that, we open curly brackets and we put the first command that I want to execute and the second, and we end each of those with a semicolon, and then we close the curly brackets. And then I have an else statement, and again you can use curly brackets if you want to include multiple else statements here. So in general, the structure of the code will be this. So if A is true, then you execute B, else you execute something else, which is C. So in this case, either B or C will be executed depending on whether A is true or not, or true or false. And then the program will, after executing B or C, it will move on and it will execute D part of the code. Now, you can also have an else if statement. So here you may have multiple conditions, multiple things that could happen. So here the else statement is used when nothing earlier, nothing above that is true. So if all else fails, then you have else. That's what you do C. Now you may want to check several conditions. So for example, let's define an integer and then initialize it to the value 7. And then you want to check if k is lower than 5. And then you print out the phrase less than 5. But now you want to check if that number is greater than 5. And in that case, you print out greater than 5. To do that, you can use else if. So you have if and then k lower than 5, and then else if k greater than 5. And then if none of these is true, then you have the else that ends the whole block. So you have if and then else if, and you can have multiple else if statements, which is like the first is always if, and then you can have many else if statements, and then in the end the last one is that if everything above fails, if everything above it is false, then we're gonna execute the last else statement. So if k lower than 5 is false, so if that's false, and then if k greater than 5 is false, then necessarily k must be equal to 5. So in that case, we're gonna print out the phrase equal to 5. Okay, so the general structure, as you must have guessed by now, is if A is true, then B, else if C is true, then we do D, and if none of this is true, else we do E. And as I said, you can have multiple else if statements. So here's an example. We have k equals 273, and then I'm checking if k is lower than 0. I'm printing that k is negative. And then if k is lower than 10, then I'm saying that k has 1 digit. And then if k is lower than 100, I'm saying that k has 2 digits. Else if k is lower than 1000, I'm saying that k has 3 digits. And then I can end this whole thing. If all of these are false, then I can just say else, and just say that k is larger than 999. So it must be 1000 or greater. So it will have 4 more digits. Okay, so that ends this video. Thank you for watching.